So this is section 6.2, trig functions, but comparing it to the unit circle, which we've already learned. So I want you to look at the picture that I have drawn here and remember the 30-degree angle that we entered into the unit circle with the triangle that it made up. Going to the x-axis, there's a right angle right there. This is a 30-degree angle. And we knew that 30-degree angle had the following values: square root of 3 over 2 and 1/2. And we also talked about with the unit circle that this is the cosine value and this is the sine value. But let's look more specifically at a few details. With a 30-degree angle in a unit circle, remember the radius is 1. Now the radius is not 1 on every circle. The radius is 1 in a unit circle. And that value, this root 3 over 2, is the distance across x. It's the distance that we would have to travel from the origin across the x-axis. Then we would travel this distance up, and if we traveled right root 3 over 2 and up 1/2, we would end up landing on that point on the unit circle. Well, if you think about that, every single point on the unit circle, the sine value, or on any circle, the sine value is going to be y over r, in which this case 1/2 over 1, which is just a half. Cosine is going to be x over r, and tangent is going to be y over x, because remember the y value over the x value here gave us our tangent value, which was root 3 over 3 for the 30-degree reference angles. Well, let's take a look at this now. This is now point xy, any point xy. It's any point xy on the unit circle with any radius of r. This distance across is still x. This distance right here is still y. And it doesn't matter if that triangle is in quadrant 1 or in quadrant 2 or in quadrant 3 or in quadrant 4. So we're going to create a concept where, using the 30-degree angle, we are going to find the other measures without our unit circle. We're going to find some other values without using our unit circle. We're going to use a reference angle chart instead. So let's take a look at our 30-degree values. Let's just do the first three, 30-degree values. What is the sine of 30 degrees? The sine of 30 degrees is 1/2. There's the first blank in my table. The cosine of 30 degrees is root 3 over 2. And the tangent of 30 degrees is root 3 over 3. And those three values just came from the 30-degree angle on my unit circle. Well, where could we find the cotangent values? The cotangent value is the reciprocal of tangent. Now, I'm going to take this value, root 3 over 3, and I'm going to flip that over, 3 over root 3. Now, that's the reciprocal of tangent. Cotangent is the reciprocal of tangent. But we have to rationalize it. And we're going to recognize that that equals 3 root 3 over 3. These three cancel, and my answer is just root 3. Now, that's kind of a pain to calculate. So, wouldn't it be great if I only had to calculate it on this one table and then never again? So we're going to think about that in just a minute. We're going to need that in a minute. But let's just write down root 3. Now, what's the secant value? It's the reciprocal of cosine. Secant is the reciprocal of cosine. So I'm going to take it and write 2 over root 3. I'm going to rationalize it. Times root 3 over 3. That's going to give me 2 root 3 over 3. Now, there's nothing there I can mark out, so that is simplified. And then cosecant is the reciprocal of sine. Well, what's the reciprocal of 1/2? 2. So we have filled out the first column of our reference table, our reference chart, okay? And I want you to recognize that we're going to use this for just a minute. We'll come back and fill these in later, but we're going to use just the 30-degree angle for just a minute. On our next page, it asks us to take a look at the 150-degree angle. Well, the 150-degree angle is right here. Now, can you make a triangle that has a 150-degree angle in it? Can you make a right triangle? No, you can't. So we are going to draw a reference triangle instead. We know that 150 degrees has a reference angle of 30 degrees right there. Remember, we learned that way back in section 6.1. Actually, we learned that in our unit circle because this is part of the bow tie of the 30-degree angle. So its reference angle is 30. And I'm going to draw the triangle there. Now the difference is this one is left and up. So the values were negative because x is negative to the left, root 3 over 2, and positive 1/2. Now when you look at that, how is this value different from the 30-degree angle? Well, the only difference is the x value is negative because when it says y, why is it different? Because it's in quadrant 2, x values are negative. We know in quadrant 2, x values are negative. But everything else is the same. So if I wanted to find the sine of 150 degrees, I could look at my table here and look at the sine of the reference angle. It's 1/2. And in quadrant 2, up is still positive, so the sine of 150 is 1/2. I didn't have to memorize this if I use the idea of reference angles. Now I know some of you are mad saying, well, I memorized it, and that's fine. Go ahead and keep using that, but just know that you now have another method for finding the sine of 150 degrees. The cosine of 150 degrees, let's look at our table. It's positive root 3 over 2, but we shifted to quadrant 2, so it's going to be negative root 3 over 2. So the values didn't change, just the sign changed, the SIGN, the sign, the positive, the negative. Tangent of 150, let's look at the 30-degree. There it is, root 3 over 3, so I'm going to put that in, root 3 over 3, but it's in quadrant 2, so it's negative. So we're going to do the same thing for the 210-degree angle, and it says draw a diagram. So let me draw a picture. Here's the 210-degree angle, and we know that that's all right there. That's 210 degrees. Well, you can't make a right triangle with that, so we're going to draw our reference triangle instead. We'll put our 30-degree angle in there, but this is left, so this is negative to the left, and it's down, so anything in this quadrant on the y is going to be negative as well. So we're going to look at our chart. We're going to write sine of 210, cosine of 210, tangent of 210, and we're going to go back and do cotangent of 210, secant of 210, and cosecant of 210. Now whatever signs we get here, positive or negative, they're going to match over here. So let's fill in our positives and negatives first. This is down, so sine is going to be negative, which means cosecant will be negative. This is left for cosine, so cosine will be negative and so will secant. Negative divided by negative means tangent would be positive and so will cotangent. Now once I have the sine values written down, the SIGN, we simply look at our table, and we are going to copy those values down. So for sine, we're going to put 1/2, cosine, root 3 over 2, tangent, root 3 over 3, cotangent, root 3, secant, 2 root 3 over 3, and cosecant, 2. And we are done.